carbon dioxide, CO2. It is often talked about because of the hole in the ozone, for a series of reasons. Perhaps not everyone is aware that carbon dioxide is also an excellent gas that can replace traditional refrigerants, such as the classic freon, which are rightly considered responsible for the depletion of the ozone layer. The evolution of refrigeration systems in recent years has pushed towards the search for new gases that limit the greenhouse effect. These new gases are either gases, let's say, of ancient memory like ammonia, which on the other hand has significant implications in terms of its toxicity rather than flammability, and the latest born is CO2. More and more air conditioning, refrigeration, and cooling systems are being developed that use carbon dioxide, CO2, as the gas in the thermal cycle. CO2 is a natural gas which therefore has a decidedly green appearance. But what are the implications? Let's say that from an environmental point of view, it is definitely interesting. From a practical point of view, it brings some challenges in implementation. The difficulties are that CO2 undergoes state changes at very high pressures. Very high. I'm talking about 100, 120, 130, 140 bar, 70 bar, pressures not reachable by normal refrigeration systems built up to now. I remind you that typical freon gases have maximum working pressures in condensation of 40 to 45 bar, not exceeding this limit. Consequently, all the components that are typically utilized must undergo a technological upgrade. There are already functioning plants, and therefore the components evidently already exist for these pressures. But not at all power levels. I have to say that regarding compressors, the issue is resolved, maybe not for all sizes or all powers, but let's state that there are already compressors available that can operate with CO2. The difficulties arise at the level of fittings, because clearly it is necessary to study fittings of pipes that can withstand these pressures. Clearly, the opposite advantage is that with these pressures, we have low volumes, and thus the pipe diameters can be reduced. Key topic: heat exchange, heat exchangers, condensers, evaporators. In this case, it is necessary to study specific exchangers for CO2 applications. They can be soldered as evaporators or as condensers. They can be heat exchange batteries when we have air condensers. In any case, these are devices that are specifically designed for this type of pressure and to work with CO2. There is already a very wide range for these exchangers that also reaches interesting powers. However, it's a study and development phase for these apps. If interested, we can discuss it.